Hello.
Hello.
Camera in just a minute. I'm just drinking a smoothie, and I'm going to put them up right now for you that you can try. All right, so try that warm-up problem. Hello. Good afternoon. Happy Wednesday. Um, I hope you're having a good day. I put up a warm-up that you can start on. We're waiting for everyone to get here. Okay, hopefully you're working on those warm-up problems. I know you know the answer. That's not the concern, right? The is, can you write the steps and show it with integer chips? That's the key. All right. Also putting document, I'm trying something a little new today. I know, because we can't try more new things. I put it in the notebook under the collaboration space. So you want to try to see if you can access the document in the collaboration space. That might be a nice alternative for some of you. Just making separate documents just so you see how it works. All right. Who wants to explain, share step for number 1 on the warm up?
I'll do it.
I'm ready.
This is how it looked. The first one, I put 4 positive chips and then added, sorry, I put 4 of the negative chips and I put 9 of the positive ones. And I know those, you can not cancel. There was a right term for that. I just did the homework too. You can subtract them. That's better than, I forgot the verb, the term. My answer was 5.
Who can help Betty out? Let's talk the steps. So step 1 is what?
Drawing out the 4 negative chips, which would be my red chips.
So step 1 is model both add-ins. Yes?
Yes.
Model both add-ins. What's step 2?
Why can't I think of the term now? Can someone help me?
Yeah, somebody help her out, man. What's step 2?
I just watched the video on why not to use canceling, and I want to use cancel now.
Zero pair.
Step 2.
There you go. 0 pair. There's
Zero pairs in a minute. Step 1, model both add-ins. Step 2, join them together, since addition. Yes? Step 3, simplify any 0 pairs.
Simplify is the word I was looking for.
Step 4, count the remaining chips. Are we confused? Did we not go over that yesterday? I feel like we said that more than once yesterday.
We did.
Yes? Brave Betty put her work out there. Nobody's helping her out, man. Alyssa tried to help you in the chat, by the way.
Oh,
Alyssa
thank
said
you.
0 pairs. Yeah. Okay. So now what brave soul, these are the kind of things you're going to have to do on your final, right? On your oral exam for me. I love chip model questions on the final oral exam. Yeah. So if you're like, ooh, I know the chip model. If you can't do what we just did right now, you better practice, right? Okay, Bethel, did you want to volunteer for number 2? I thought you were holding up your like, ooh, I'm ready.
No, I thought something was in the bottom of my board, but I'll go ahead. I need the practice.
All right, go for it.
So I wrote down, since this is a subtraction problem, I wrote down the minuend and subtrahend. And so 2 and 3. And so I know, because of the integers in front of the 2, I know that this is, and there's no number before the minus sign, I know that this is a -2. And so I put down 2 negative chips. And then I'm looking, I see that this integer, the integer is between 2 numbers. And so I know that the 3 is a positive 3. But so I have to take away 3 from, I have to take 3 positive chips, positive or 3 negative chips. I can't remember. But I
Positive,
have no
you were right. Keep
positive
going.
chips. So I see that I have no positive chips to take away. So I have to put in 0 pairs to take away some positive chips. So I put down 3 0 pairs. And so now I have enough positive chips to take away 3. So I take away 3 positive chips and leave the 3 negative chips behind. And so now all I have to do is just count up the difference, and I have -5 chips.
Do you agree? Good job. You should be giving Bethel party hats. You should be giving her something, man. She did a great job. So here's an important question. In subtracting with integer chips, do you model both numbers on step 1? This is to everyone.
No.
No. You only model which one?
The -2. So in this case, -2 chips.
And I thought I was reading Alyssa's lips. She was saying minuend. Yeah, she's saying minuend. Yeah, so always model the minuend and then decide. So if you're trying to prepare this for me for your final exam, you would write down in words, step 1, model the minuend. And then you would have a picture with 2 negative chips. Then step 2, you would say, I need to take away 3 positive chips, but I don't have any. So I'm going to add 0 pairs. And then you would have a picture with the 2 negative chips and the 3 pairs, the 3 sets of 0 pairs. Then your next step would be, now I can take away 3 positive chips. And you would show a picture taking those away. And then step 4 would be count the remaining chips, right? And you would have a picture of 5 negative chips. And yes, I'm a little concerned when people ask me questions that I know were on the syllabus quiz and I know were on my syllabus. So if you don't read the syllabus, I'm going to start getting annoyed with, Evelyn, I'm so happy you clarified. And other people, I'm sure I've gotten more than Dutch from just you, Evelyn. I've gotten lots of questions about what's happening next. So you do have an oral midterm and final. Yes? So you have an oral final exam coming up. I know it's quick. And remember, I just told you yesterday it's going to be lots of fractions. I know you're super excited. Yeah, I can see it on your faces. Good job. So yes, you'll have an oral final exam too, and a part of it Canvas still. Okay, so patterns in multiplication. Did everybody see the doc? I'm going to share it on my iPad too, just so you can see. I added in our collaboration space. Why is it not there? I bet it didn't sync. My internet says it's slow. So it must not be there. Darn it. Hold on. And is anyone on my OneNote? I know somebody uses it. I can't remember. Sunita, are you on? Oh, Alyssa, can you see in the content library? Can you see any team docs? Okay, this is really weird because I must have put it in the wrong class. That's annoying. Hold on one sec. I'll just move one over there.
I don't see anything. I only see the
Yeah.
weeks.
Hold on, let me see if you will. Go to the collaboration space and see if you see where it says, there should be a document now that says,
I see which one doesn't, and then using the collaboration.
I don't know why it's not syncing. That's so annoying.
Yeah, which one doesn't belong?
Yeah, I see which one doesn't belong, but it's just not syncing with my other one. That's okay. It's okay. That's why I didn't do it that way. Let me share. That's so dumb. I think my internet's having trouble, so it's okay. I'm going to share my screen this way. Does everybody have access to the document that I emailed you? Yes? Okay, good. So, and maybe you can see my screen. Can you see it on my screen right now? Okay, good. So we're going to talk about patterns in multiplication and division. And when we do these patterns, what I want us to do is, I do not want you to do multiplication. Okay, so listen very carefully. I do not want you to do multiplication. If you already started filling this in, you are not following directions. There's a method to my madness. Please do not start filling it in. If you already did, you might have that deer in the headlights look right now. Okay, so this is what I want you to do. Okay, it says, let me see if I can write on this page. Why can I not write on this? It says, in each of the following sets of problems, so we're looking at problem 1 vertically, complete the products you know, then look for patterns to fill in the missing entries. So I want you to just look for patterns. So for example, I want you to look down this column and go, oh, do you see how these are all 4s? If I look vertically down the first column, it's just 4, 4, 4, 4, 4, 4. So I'm just going to continue that, and I'm going to write 4s in those spaces. All right. Then in the next column, it says 3, 2, 1. What pattern is happening there?
It's going down 1 digit.
Yeah, it's going down by 1. So I'm just going to continue that pattern. So it's going to be 0, then it's going to be -1, -2, -3, -4. Then if I look at this last column, I go, okay, well, I know that they gave me 12. So 4 times 3 is 12, or 4 copies of 3 is 12. I probably know 4 times 2 because I already know whole number multiplication. So 4 times 2 is 8. 4 times 1 is 4. And it's about here when I should start seeing this pattern, right? Right here from 12 to 8, I'm going down by 4. From 8 to 4, I'm going down by 4. So I want to continue that just with patterns. I don't want you to think multiplication. I just want you to do patterns. So you're going to go 4 minus 4 is 0. 0 minus 4 is -4, and continue that. Okay. Then I want you to do something very similar on number 2. Notice now that the second factor is the one that's staying constant. So you're going to fill in 5s here. This last column, I showed you the product of 4 and 5, 3 and 5, and then this would be 2 and 5. So fill this in only with patterns. Then I want you to write a rule for multiplying a positive number and a negative number. Don't write the rule that you already learned, that you already knew. I want you to use the information on these problems 1 and 2. This is where I have a positive number times a negative number. find the area in 2 that has a positive and negative number, and then write your rule. After you finish that, we'll talk, and then we'll continue with this should be number 3 and this should be number 4. I don't know why that numbering's wrong. Okay. So I'm going to put you in your breakout rooms to try that and talk. And you might be like, this seems really weird, but you guys learned rules before you learned anything else about multiplying and dividing integers. You just learned a rule, you didn't learn why. So that's what we're focused on today, is why. Okay? Any questions on what you're doing in your breakout room? You're just doing 1 and 2 and writing the rule. Okay, I'm going to stop sharing. We'll see, you might be done before I get your breakout rooms ready, but that's okay, because then we can talk and then you can do the other thing on your in your breakout rooms. Oh, it's so much faster when you guys have your numbers. I so appreciate that. All right. So go to your breakout rooms, talk for a minute, and then we'll chat. All right, welcome back. Sorry, I know that was fast, but I think you were easily done, right? No worries. So what did you write for your rule for multiplying a positive number and a negative number? McKenna, I'm ready.
So I just put multiplying a positive number and a negative number always results in a negative product.
How many of you wrote something similar? Anyone need to add something, or did anyone have anything additional?
Well, I understand why that's the case for when the like when it's 4 groups of -2, that makes sense why it'd be negative, but I don't understand how you would model -2 groups of 5. That doesn't make sense to me.
Yeah, -2 groups of 5. I agree with you, and we're going to discuss that very soon because it's concerning. So what we could, let's just say we buy it right now, but what could we say, why could we say we buy it? Did we learn anything with whole numbers that we could apply to integers that would tell us it's okay if the minuend, if the first factor is positive and the second factor is negative, or if the second factor is negative and the first factor, I think I just said the same thing. I'm speaking in tongues right now. I don't know what's happening. If the first factor is positive and the second factor is negative, I have a negative result. Or if the first factor is negative and the second factor is positive, I still have a negative result. is there anything you already learned that could justify that mathematically?
Well, we have the commutative property, but that's more with numbers and not so much with negative signs, but it could potentially be applied.
Yeah, so we do have the commutative property of multiplication, and this still is multiplication. Now, we talked about whole numbers, and if integers are whole numbers and they're opposites, then it must kind of follow those same rules or those same properties. So, but we're going to talk about how we model that, Hannah, because you're absolutely correct. When we model two groups of -5, I can see it. But when I try to model -2 groups of 5, that's a little troubling, right? So we're going to talk about that in just a minute. What I want us to do is we're just going to buy it for now. We're going to say, okay, I believe it. I believe that when I multiply two numbers in either order, if their signs are different, then the answer is negative. Perfect. Now I want you to do the second number 2. Apparently how my worksheet is numbered, which is a little irritating. And you know how many times I fixed that? So apparently I'm not very good at fixing that, just in case you're wondering. So again, now we're gonna believe what we said for our rule. So now notice that we have -3 times 2 equals -6. That's a given for us. The next one would be -3 times 1 would be -3. That's gonna be a given for us. And so I want you to, again, fill out this second half of this first page using patterns, again, just patterns, and then write your rule for multiplying two negative numbers, okay? And then we'll come back in just a minute. Don't move on to page 3 yet, or page 2, okay? Kelsey, that's all right. I think we're having lots of internet issues here too. So just stay here for a minute and just finish that, and then I'll bring everybody back in just a minute.
Okay.
Hello, you're back. Sorry, I keep throwing you in and out of your room, and some of you are getting kicked out. So sorry about that. I figured out my problem with OneNote. I was putting it in the wrong notebook, so you're welcome. Yeah, it's nice. So now it's actually there in the collaboration space, so you should be able to see this document that I'm writing on right now. So, and if I put it in the collaboration space in the future, some of you might like it in OneNote better, okay? Just so you know. So what was the rule you guys wrote for running the rule for multiplying two negative numbers? And so it's from here and over here. What did you notice just with patterns, what happened?
With two negatives, two factors of negatives will equals to the product of a positive.
You guys all agree? How did you write your rule? Did you write like when multiplying two negative values, the result is positive? Something very similar to what Bethel just said and what McKenna said earlier with the negatives and the positives, but now our answer is negative. Now, this may seem like it wasn't a proof, and it wasn't a proof of why this is true. But remember we talked, I can't remember if it was yesterday or last week, we talked about how they used to say negative numbers didn't exist. Yeah, do you remember that? And so when they said that, they just dropped it. So then they thought about it for a while, and mathematicians came up with, no, negative numbers do exist, but we don't want to break any of the rules we already have. So, and our entire number system is set up with patterns. So if you look at this just with patterns, you go, oh, if I am increasing this by 3 each time, that must be true here. And so that results in when I multiply a negative value times a negative value, I end up with a positive value. Not a proof, but intuitively, it feels a little better than probably whatever your teachers told you in elementary school, because some of you probably asked this question, right? Why is it when I multiply two negatives, I get a positive, right? And you had some English teacher explain it to you. right? That when you have a double negative, that actually means a positive. Did anyone have experienced that? And you're like, okay, stop giving me an English example. Can you give me a math example? Because I believe you, but so this one was hard. Think about this. This was hard for ancient mathematicians to do. So if it's hard for us and our students, it's no surprise. If you try to put it in a contextualized situation, it gets messy, doesn't it? Right? We start thinking about it. Okay. So, and we'll talk about how we can do that too. So, but at least it's a little better than just saying, because I said so. I was just going to show you something, and now I don't know what it was. Hold on. Okay. Let's talk about this, and then we'll go to our number lines, and I'll probably switch to my screen instead. But if you guys want to make a copy, if you like OneNote and you're using OneNote, you can copy stuff to your notebook too if you want. Okay, so remember that multiplication and division are inverse operations of each other. So 12 divided by 3 equals, 12 divided by 4 equals 3, since 3 times 4 is 12. So A divided by B equals C means that C times B equals A. Remember we talked about this with division by 0? This was kind of our nice way to connect multiplication and division. So if we're doing negative 12 divided by 4, you want to think 4 times what gives me negative 12. You could also think of it with our chips. You could go, okay, I have 12 negative chips. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This time, let's think of our divisor as the number of groups. Okay, the number of groups. So I want 4 groups. So I'm going to split this negative 12 into 4 groups. Well, I can go, there's one group, there's one group, there's one group, there's one group. So there's 4 groups. So 4 groups of negative 3 gives me negative 12. Right? 4 groups of negative 3. Now, there's a reason that I chose for my divisor to be the number of groups instead of the size of the group. I didn't say the size of the group was 4 because the size of the group would be negative 4. Does that make sense? So I was very careful about saying my divisor is the number of groups, not the size of the groups. Yeah. Okay. This is a nice summary, and kids will write this summary after you do, say, a pattern activity like this with your students. And I have seen the most complicated rules in the whole world for this. Teachers like to overcomplicate this. Now, maybe it wasn't a teacher, maybe it was a kid. Has anyone ever seen this? Anyone seen a poster or a table like this? Yeah. So now we have 4 rules, right? I'm pretty sure we don't need 4. It seems like too many, right? Because the rules can be really just 2 rules, right? I've also seen this one. Tell me if you've seen this one. Sorry, that dot shouldn't be there. Let me get rid of that dot. Okay. Has anyone seen that one? A couple of you have. Yeah, some of you are chuckling. Okay, so I don't know why teachers are muddying the waters, right? Show them patterns. They could refigure them out, right? You could draw these patterns just like division was 0. They could figure it out. I'm going to tell you 2 funny stories. First of all, I didn't see this one until I was a teacher, right? And this one, as soon as someone wrote it on the board, I was like, oh, I'm so confused. Like this one kind of makes sense, I guess. When I'm wide awake, I'm happy. I don't know, maybe that's what that is. And then when I'm sound asleep, I'm happy, right? So in other words, when I multiply two positives, I get a positive. When I multiply two negatives, I get a positive. And then these right here, let me use a different color for that. These two, I was like, wait a minute, what is that? If I get punched in the eye, I'm sad. No matter if it's my right eye or my left eye, I'm still sad.
Can I
Oh.
explain how the smiley faces were explained to me as a child?
Please, please.
They're supposed to be representations of friendships. If you have two friends with a positive personality, then you're going to have a good friendship. But if you have a friend with a negative personality, you're always going to have a bad friendship. And if two friends have a negative personality, they'll get along with each other. And as a child, I'm like, but that doesn't make any sense.
I love that, Elena, because you're right. It doesn't make any sense. And so that analogy is not helping me understand it more. And like I said, as soon as the teacher wrote it on the board, I was like, wait, who's getting punched in the eye? So I was very confused on that. Did anyone else see this before? No? Oh,
I've never seen
Karina.
that before.
Who said that?
Me, Vanessa.
Vanessa. Okay, and was it a friendship analogy?
No, I've never seen that, the smiley face one. I've seen the one above, but not the smiley face one, which was, I was just kind of confused, like how Elena explained it. I was like, well, how does that work?
Yeah. And so was Elena. She's like, that didn't help me at all. Yeah. And Karina, have you seen the smiley faces or the top one?
For me, I saw it both ways because I think it was my in my regular resource classroom and then my IEP classroom. But for me, like seeing the smiley faces and sad faces kind of help because I'm an extremely visual person. So even though it like looks strange to me, it helped me remember, okay, if I have two of the same, that's a good thing. If I have two different things, it's a bad thing. So when I would get problems, I'd be like, oh, negative, oh, positive. It just helped remind me.
And that's probably where it came from. It helped a kid at some point, and so then that teacher just perpetuated that. So if it works and it helps a kid, I'm all for it. It never helped me. It confused me more than anything. Let's go up here to this one, and I'm going to tell you a little story that a teacher told me when I was watching my student. I was doing my internship, so I was just observing, right? And I literally could not keep a straight face. You can imagine me sitting in the back of a 7th grade classroom trying to be a professional, right? I'm going to be a teacher. I was just like you guys, right? And I was sitting in this classroom and the teacher started explaining and I was like, don't laugh, don't laugh, don't laugh. And like, it was terrible. I had to excuse myself from the room. I'm very mature, let me tell you. And that's why I'm appropriate in middle school, because I was very immature. You should have seen me trying to teach human growth and development. Not my cup of tea, let me tell you. It was a very challenging few days for me. But let me tell you this story. So if you see a line that is a line like this, right here, and you were saying good guys or bad guys, would positives be good guys or bad guys? Positives would be good guys, right? Negatives would be bad guys. Winning would be positive, losing would be negative. Do we all agree with that? Like that analogy is making sense. Okay, are you ready for how muddy it's going to get? And picture me sitting in the back of the classroom cracking up, okay, in front of like 35 7th graders. Yes. Okay, you ready? Here's this one. When the bad guys lose, that's good. And I'm telling you, I'm going to do it just like the teacher did, because that's what made me lose it. Okay. When the bad guys win, that's bad. When the good guys lose, wait, did I write it wrong? When the good guys lose, that's bad. And when the good guys win, that's good. I was like, wait, what, what, what is happening? And she was dead serious. Her delivery was dead on. Like she said it about 3 times. And I'm telling you, it was not just me who was losing it. Like I left, I came back, I pretended I had the cough or something, right? I came back and there was this kid sitting in the class that was like, am I dreaming what's happening right now? Because, and so finally the kid, after like round 3 of this, the kid raised his hand and he goes, so what you're saying is if the signs are the same, it's positive. If the signs are different, it's negative. And she's like, yeah. And he goes, I don't need to remember that story, right? And it was hilarious. Like the kid was worried that the story was going to be on the test. So again, maybe it helps some kids sometime. And that's why it was used. I'm all about that. But sometimes we teach these strange things thinking it's clearing it up and it's not clearing it up. If you show them something like this, where they can investigate it, and Hannah, we're going to get to that part in just a minute to kind of try to draw pictures of it and make sense of it, it will sink in deeper and they won't necessarily need all of these things. If they do still, that's fine, but at least show them where things came from instead of just showing them a shortcut. Okay.
Yeah, I would just like to say it's cool to have like a visual one and then like also say it in a quick version because because you're gonna have like a whole different range of students and all students learn differently. So it's important to
Absolutely.
show too.
Absolutely. And you have to reach all of your students. So you have to have more than one tool. But this tool will never be in my toolbox right here. Yeah, I can't say that to students. I just can't. Every time I try, I'm going to lose it. But hence why I taught 8th grade, right? I didn't teach young elementary, because it wasn't my cup of tea. Okay, so if the signs are the same, the result is positive. If the signs are different, the result is negative. All right, now let's get to Hannah's concerns because it is a real valid concern. And I'm not sure I love this explanation, just so you know. I'm upfront about that right now. Oh, sorry, let me go back here. Let me go back to my slides. So if you're gonna do a number line to evaluate 3 times 5, go back to our original model for whole number multiplication. That's 3 copies or 3 groups with 5 in each group. And if we were doing it with our chips, we would say, okay, these chips are going to be yellow. So we're going to say 1, 2, 3, 4, 5. There's 1 copy. 1, 2, 3, 4, 5. There's 2 copies. 1, 2, 3, 4, 5. There's 3 copies. And so our answer would be 3 times 5 equals 15. Now that was a nice one because it was positive, right? So it's okay. And we could show it on a number line, 3 copies of 5. So there's 1 copy, 2 copies, 3 copies. So that's 1 copy, 1 copy, 1 copy. That should be a flashback to what we've already done, right? Everybody with me? Okay. And I have that written here. Now, what about if we're doing 3 times negative 5? Can you fill that in? 3 times negative 5. Fill in your number line and fill in your integer chips. So think of how many copies and what is the size of the copy. All right. Did everybody have a chance to finish? Not yet. Okay. Okay, we ready now? We good? Who would like to share this idea? Their idea here. How many groups? How many in each group? What it would look like? What do you got?
So for the number of groups, that would be 3. The number in each group, so each copies would be -5. And so the product would be 3 groups of -5. So, and so that multiplication would be 3 times -5 equals -15.
Yeah, that wasn't too bad. How about on the number line? What'd you do?
So on the number line, I started at 0 and I just, instead of going forward, I just went back. So I went jumped -5, and then I jumped another -5, and then I jumped one more -5 to get -15.
Very nice. So again, like Hannah said, that one doesn't bother me, right? I can see that. 3 groups of -5. I'm good. Any questions on that? Is everybody okay with that one? Because now it's going to get, yeah? All right. What about this? I want you to think for a couple and see if you can think of any mathematical strategy that we've done, we've learned, properties, all of those things to make this more digestible. Okay, so I'm going to give you about 2 minutes to think, and I want some strategies. I don't want, I just don't know. Okay, I want you to try something, think about something. Okay, I'm going to give you 2 minutes to think. All right, sorry, my camera just started going crazy. Okay, I want to hear some ideas.
I can tell you my thinking. The logic isn't terribly sound, but it was a start. So if you can read -3 as -3, don't know if that's allowed. I think it is based on one of the questions we did earlier, but not entirely sure. But if you take away 3 groups of 5, then you will have taken away 15, which, and then you make that takeaway be a negative again, and then you have -15.
Okay, what do you guys think of that strategy? Bree's like, it's good. I love it. You're perfect. It's a little concerning, right?
Yeah.
Because now we're likening multiplication to subtraction, right? If we're using takeaway.
Yeah.
So I'm not saying it's terrible. Like you said, you're like, I'm not so sure about this. But do you see my worry is that it's connected to subtraction instead of multiplication? Let's hear some, but I totally followed what you were saying. What are some other ideas?
So, oh, I'm sorry.
Oh, I was gonna say I use the commutative property of multiplication because we know -3 times 5 would be the same as 5 times -3. So then I had 5 groups of -3. And then that was like what we did in the last problem. So I got -15.
Nice. That's a nice loophole, right? You're like, oh, I could just do, if I reverse the order because I know the commutative property of multiplication, I'm going to say 5 copies of -3 and I still get the correct answer. Good thinking, Amanda. Bethel, what were you thinking? Same thing?
So no, I was just gonna I was thinking that -3 is just the opposite of +3. And so I pretended that that's 3, no negative. And so I did the equal groups. So 3 groups with 5. And then I plugged in the integer to make the positive into a negative, since it's the opposite.
Ah,
That's what I did.
okay. Nice. So you were basically thinking of it like this. So the opposite of 3 copies of 5.
Exactly.
Yeah. And Hannah, I feel like you were going to say something before about Amanda's.
Yeah, I mean, I love the idea of the commutative property, but what's the point of differentiating between 5 groups of 3 or 3 groups of 5 if you can just switch them willy-nilly?
I agree. Remember when we did it with whole numbers, we had that kid that modeled the wrong one.
Mm-hmm.
Yeah, and so we were troubled by that. So I agree, it is troubling. Now, if kid can defend their mathematics knowing the properties, I might be okay with it, because by the time they do these operations, they're in 7th grade. So they no longer need that physical model for multiplication, right?
sure.
They've moved beyond that and they've moved to this abstract because they're getting prepared for algebra. So, but I get it, Hannah. I agree with you. What do you think of Bethel's? And anyone can answer this. What do you think about Bethel's idea right here? Everybody hates it, Bethel. What's happening? Nobody's saying anything.
Please say something. You won't hurt my feelings. So
I'm just gonna keep talking. I like it. It reminds me of, you mentioned this earlier, some teachers taught us the negative in front of a number is like multiplying it by -1. So that's what this reminds me of. In which case I would be like, oh, the distributive, I don't know. It gets a little bit confusing too, but I don't know, all of them are a little confusing, so.
Yeah, no, I like what you guys are talking about, because we did talk about opposites, right, already. And so the opposite of 3 is 3. So if we can apply here, and -1 times that number, you imagine the -1, so a teacher could help you with that. I like just the vocab opposite. So if you use the opposite of, you're still looking at 3 copies of 5, and then you're taking the opposite of. Any other ideas, problems, concerns? You like Bethel's, don't like Bethel's? Hannah liked it, I liked it.
The one thing that I have a problem though is, actually now I'm thinking about Paulina, it's just drawing it on the number line.
That's what I was gonna ask. How would it
Yeah.
look like in the number line?
Oh, let's go there. Look at this. You see that I wrote the opposite of 3 copies of 5? So numbers in each group is +5 now, which it always was +5, right? From our original problem, this was a +5. So, and now I did 3 copies of +5, and then I take opposite. So on my number line, I drew a copy of +5, 2 copies of +5, 3 copies of +5, and then remember when we did that line of reflection and we talked about taking the opposite? So that's where this came from. I'm not saying it's the best, but I'm saying at least it's something, right? More than you got before. I'm going to give you time to catch up with that. And then we're going to talk about the true challenge for you. And I'll put you in your breakout room to discuss this one. What are you going to do for the next problem that's -3 times -5? Okay, -3 times -5. Are you all caught up? Or you need another minute? All right, I'm going to put you in your breakout rooms. Nobody's crying yet. Tyler, what number team are you on?
I am so sorry I forgot to put that in. I'm on 4.
Perfect. Nope, you're good.
Thank you.
Nope. Hi, Elena.
Hi, my group should be in shortly.
Oh, you're good. No, they're coming back.
How's your day been so far?
Oh, good, except for I'm getting tired right now.
Oh, you think it's the weather?
I don't know. It looks kind of sunny outside, but I think it's just because I've been sitting at my desk for too long.
Maybe walk around.
Hello? Yeah, I need to. Right after this, I need to walk around. But my daughter has a soccer game today, so I'll get to go
Ooh.
outside and watch that. Yeah.
That's
And
nice.
I don't bring a chair because I'm a little excitable. So I stand up the whole time. So then I'll feel better, right? Then I'll be like, oh, I've been standing so long. There's never a happy medium there. So, okay, good. Did anyone figure out a way to model this?
I
Tyler?
kinda. Oh.
Oh, sorry, Elena.
No, let Tyler go first.
Okay.
I apologize. I'm kind of still recovering from numbness, so I might sound a little dumb. Basically, what I did was I took the opposite of -3 times -5, and I showed that here on the number chart by taking 3 groups of -5 and then the opposite of that.
Okay, so you did the opposite of 3 copies of -5, right? Nice, and you showed it on your number line. You went 3 groups of -5, and then you took the opposite of it. Elena, what were you saying?
Mine is exactly the same as his.
Oh my gosh, great minds think alike. Did anyone try anything different? I have had students who go, I know that a negative times a negative is a positive, so I'm just going to model 3 copies of 5. I'm like, but you're not really showing me what's happening. And they're like, yeah, because I didn't like it. So yeah, that's what I did too. If you look in 3 copies of -5, and then I took the opposite. How do you take the opposite when you have actual chips? And I don't know where my chips are. They're like, they've been eaten or something. I don't know. I'm going to find them after class. If you can imagine, you put out 3 copies of -5. So you have 3 groups of -5 chips in each. So you have 15 red chips on your table in front of you. And then when you do practice this beforehand too, as well. When it says take the opposite, can you imagine what you have your students do with those actual chips? Flip them over. That's what they do. They flip them over. And so they get used to that idea. So they'll go, oh, I'm going to do 3 copies of -5, and then I'm going to take the opposite. And they flip them all over. I'm not saying it's the best. I'm not saying I love it. I definitely do not like the chip model for division. And if you can imagine why we don't like the chip model for division, you'll get there. Look at division. This would make sense. 12 divided by 4. We've done that, right? So we don't have to worry about that. 12. This time I did group sizes of +4 because they were both positive. So that was fine for me, right? I have 12 divided by 4 equals 3. And I showed it on the number line. Not a worry. How about -12 divided by -4? I think you'll still be okay, right? We have -12 chips. We're going to put -4 chips in each group. So our group size is -4. So again, I'm going to have 3 copies. This is not worrisome. When you get down here, how would you do -12 divided by 4? You could do it. It would be okay. You could put it in 4 equal groups, just like I modeled in the beginning. But how on earth would you do 12 divided by -4? That one is troubling, right? Like, what do I do here? I can't put them in 4 groups because it's -4, and I can't have my group size be -4.
Can you do it as a multiplication problem?
Yeah, so that's exactly what you would have to do, Betty. You'd have to change it to a multiplication problem. But that is the one where the chip model really, really just does not show you well. And so that model is very troubling. Okay, so, but at least you can move them to multiplication problems and you're okay. Do a quick flashback for me. I know we just have a minute, but do you remember how to do 14 times 23 a non-traditional way? Do it. This will be fun little warm up, right? I mean, close up because we're almost done. But do 14 times 23. Just get your math brain going again. Are you getting faster at that? Some of you are getting faster. It's way faster than the traditional algorithm once you get used to it. I did it today. Anyone do it today? You didn't have to. You could have done it a different way. I chose to do it this way. How many of you did the area model? Nice, Anita. Nice. A lot of you like that one. That's good. Now, did you notice that on it says use that information and what you know about integer multiplication to complete the rest of the problem? I've had students where I give them that worksheet and let me see if you can see it. Did I ever find it? Yeah. So right down here, I've had students literally work these out 4 times. They'll work it out here and get the answer to 14 times 23, right? Which they'll get 322. And they'll do all my work just like that over there and they'll get 322. And let's say the worksheet will go a couple problems and have this problem. They'll do all the work again. It's terrifying. And literally they'll do it again and again. So you want them to make these connections that if the numbers are the same, the factors have the same absolute value, you can just keep track of the sign, right? So like if it was me and I was doing this problem, I would do this. I would do my math for that part, and then I would just write 322, 322, 322 on all of them. And then I'd go back and I'd go, oh, this one's positive, this one's negative, this is negative. Anyone else do that? Some of you write the sign first, right? Some of you will go through and do this. Okay, this one's positive, this one's negative, negative, and this one's positive. Then you'll do the math once. Make your kids see those connections so they're not wasting time. Okay? I know we didn't finish. It's okay. I have a little bit more to do, and we'll do it for warm up tomorrow. The one thing I need you to do, oops, sorry, that's not the right page. The one thing I need you to do tonight, remember, I need you to do the Eratosthenes 6. So I need you to do this assignment right here. That assignment needs to be done tonight so you understand what's happening tomorrow. On your exit ticket, you really just have to put in the answers. But as you're putting in the answers, I just think through how to show this with chips or on a number line. Okay? And that's it. See you tomorrow.
Have a good day.
You too.